Hello, this is Seonghwan Kim. Today I want to talk about my research topic. My research topic is the investigation of the knee joint stability of normal and ACL PCL deficient. The ACL is called the 전방 십자인대 and PCL is called 후방 십자인대. And this is the schematic of the knee. As you can see, there are lots of tendons and ligaments. The difference between the tendon and the ligaments is the tendon is connected to the muscle, and tendon and muscle itself can generate its active force. But the ligament just connects the bones at the joint, and it cannot generate its active force. But it can generate the passive force if there is a displacement between two bones at the joint. So this is the schematic of the knee. And the picture on this page is the gait cycle. And I want to emphasize that the knee joint motion is important in gait cycle. And this is the EMG level profile of the gait cycle. The red checked profiles are the muscles that controls the motion of the knee. So there are lots of muscles that controls the motion of the knee. And then what is the joint stability? The definition of the joint stability is its ability to produce the appropriate functional position throughout its range of the motion. There are three conditions of the stable joint. The one is the joint should carry the load without any pain. And second is the joint should produce appropriate contact force. This is also called the reaction force. And the third one is the little change should not produce the large changes of the joint motion. Yeah. And my research will focus on the third condition. Then how the joint stability kept when doing some motion. There are two mechanisms to keep the joint stable. The one is the passive mechanisms. The passive mechanism consists of the contact force between two bones at the joint and the constraining forces by ligaments. As I mentioned previously, the ligaments generate passive force if there is a displacement between the two bones at the joint. On the other hand, the active mechanism is the forces by the action of the muscles. So see the picture right, and there are muscles that controls the motion of the knee, and the force by those muscles also contributes to the joint stability. Then we need to parameterize the joint stability, and there is a paper that defines the joint stability, that parameterizes the joint stability. Yeah, the basic concept is its potential energy. So see the picture on the right. As you can see, there are three balls, and by calculating the first derivative and second derivative of the potential energy, I can distinguish the state of particle. So like this, I can apply the idea to the joint. So the pictures on the bottom is about the modeling of this paper. The paper calculated the joint stability of the spine, the L4, L5 joint. Yeah. To calculate the joint stability, I need to know three three inputs. The one is the coordinate of the muscle and the joint, and the second is the muscle force, and the third is the stiffness of the muscle. So at first, I calculate the sum of the work done by one muscle and the energy stored on the muscle. So the energy stored on the muscle is spring energy. So I can calculate the energy in the middle, like in the middle. So I calculate the energy one muscle, and then I can calculate the stability contribution to the joint stability by operating the second derivative by the theta z. So this is the definition of the joint stability contribution of the muscle, of one muscle. So, but there are constraints of this paper. This paper calculates the joint stability at equilibrium state, and the paper ignores the passive mechanisms. So, like the passive force by ligaments and passive force, the reaction force of the knee, of the reaction force of the joint. Yeah. So I decided to apply the model to the knee joint. Then to do so, I need to model the three compartments. The one is geometry of the bones, and another one is ligament, and the third one is tendons. So I find some articles about the modeling of three compartments. So this is what I find. The following pages are what I found. And to model the bone, I found the cadaver data and its average data. So I found the geometry data of the knee bone, but I need to find more. And the second one is the ligament modeling. Some paper, the ligament is modeled as linear elastic model. So there are two parameters. The one is the elasticity, and the other one is the reference strain. The last one is the muscle modeling. So as I learned before, many papers uses the heel type model, but I need to study and investigate more about this model, but I will use the heel type model. So the picture is the schematic of the heel model, and the table is the information about the model parameters. So my main topic is to investigate the knee joint stability of normal and ACL PCL deficient, and here are the procedures of my investigation. At first, I need to simplify and model the knee joint. And there are three compartments, and first is bone, the second is ligament, and third is tendon. And then I validate my modeling. The second is to analyze the contribution of the muscle to the knee joint stability. So I simulate the normal case and investigate how each muscle contributes to the joint stability. And then I compare I calculate the joint stability of ACL PCL deficient by changing the simulation parameters and investigate what is different and what is the weak point compared to the normal normal case. And this is my research plan, and thank you for listening.